Yep, so hi guys. In this video, we will be solving this question subsets 2. In the last video, we solved subsets problem. So this problem is extension of that question only, right? So here we are given an integer nums that may contain duplicates. Print all possible subsets or set. The solution set must not contain duplicate subsets. Two subsets are considered the same if after sorting both array they become equal. Print the subsets in sorted order. Also print subsets in sorted order. See example for better understanding. Ignore null set. Right, so here are many things that we need to take care. Right, the first thing is we have to avoid taking duplicate subsets. Duplicate subsets. Right. The second thing is the elements of the subsets should be sorted. Should be sorted. Third is all subsets should be in lexicographical order. Lexicographical order. And the last thing is we have to ignore null set. Ignore null set. Right. The the question that we solved in the last video is similar, but these are four pointers which we need to take care. Right. The solution must not have any duplicate subsets. It should be sorted. What it means, it's like suppose we have this subset, sorry, array 2 1 2, right? So it's possible subsets can be 1 to 2 and 2 1 1 1 to 1, right? 1 to 1 and 2 1 1. So after sorting 1 to 2 and 1 to 2, they become same, right? So we need to ignore the duplicates. We have to keep only unique subsets. That's what it's saying here, right? They should not contain duplicate subsets. The two subsets are considered the same if after sorting both array become equal. After sorting both array becomes equal, right? And print the subsets in sorted order, right? The subsets should be sorted. And the next thing is also print subset in sorted order, right? So what it means is single subsets should be sorted, and the whole bunch of subsets, array list or 2D array, should also be sorted. right? So we have this example here, 212. So how we are going to solve this to handle first scenario, avoid duplicate subsets. Hmm. Uh, let's keep it on hold for now. The second, the elements of the subset should be sorted. For this, what we can do, we can sort the array, right? So after sorting, all the subsets that will be generated will already be sorted, right? So this thing we can handle by sorting the array, given array, right? So after sorting, our array will become 1, 2, and 2, right? Now how we are going to implement this? Let's see the previous approach, the approach which we discussed in the last question, and then we can see what is wrong with that approach, right? So we are at index 0 and the data structure is empty. Now we can either select the element at 0 or we can reject. If we select the element, we will move to first index and the element will be 1 added to our array list. Again, either we can select or reject. If we select, first element would be added into our data structure, 1, 2, right? Right. Now, uh, either we can select or we can reject. If we select at element 2, what we will get 3, and element at index 2 will be added 1, 2, 2. Right. So this is our base condition. We have received a subset of 1, 2, 2. Right. Now we will go back to the right call of this. So we will remove the recently added element, this 2. When we will remove 2, we will get back to the previous position and we will go with the right tree. So we can, if we reject the element at 2, so we will get to index 3 and our data structure will be as it is. So this is another subset, 1 comma 2. Now this tree is solved, right? So we can remove all this clutter from here. Now we will go with this call. This call is terminated. So if we can, we are rejecting the element at, we have selected the element. Now we are rejecting the element at 1, which is 2. So we will be at index 2 and the data structure will be as it is. Now we will go to, we will go to, we can either select or reject the element at 2. If we select, then we will be at index 3 and 2. The element at index 2 would be added. So 1, 2, 1 and 2. Right, and if we don't select, we will be at 3 and 1 will be as it is. So these are our other two subsets. So this call is also finished. Now we will go with this right call. So if we reject the element at 0, we will be at index 1 and the data structure will be as it is. Now either we can select the element at 1 or we can reject. If we select the element at 1, which is 2, will be at index 2 and 2 would be added. If we reject the element, it would be at index 2 and the data structure will be as it is. Now further we can select or we can reject. If we select the element at 2, we will be at index 3 and it would be 2 2. If we reject, we would be 3 and it would be element 2. Here if we can select the element at 2 or we can reject. We select the element at 2, it would be 3 and 2. This would be 3 and empty. So we have got these subsets 2 comma 2 uh, 2 2 and again 2 and then empty array. Right, now the problem here is these are duplicate subsets. Yep, these are duplicate subset which should not be included in our answer. Right. So see, what I can do is I'm just trying to scroll this a bit. Okay, there is this sign up problem. Okay, let it be. So right, we can have this code at here. So what I'm saying is, if you carefully observe, when we are at F0 and data structure is empty, we are calling this for selecting the element and for rejecting the element. Now, if we select the element, which would be suppose element 1, and the element would be added in our data structure. We are index 1 and the element is added. Now this subtree will have all the subset where 1 or ARR of 0 is present. Am I correct? Right. This will have all the subset where 1, this is the element at 0, ARR of 0 is present. So we can say we will have index 0 and combination of index 1 and 2. What all combination of these two elements is possible, we can have that. Right. And if we are rejecting this element, we are at 1 and the data structure is empty. Now we are again selecting the element which is at 1, right? We are selecting this. So selecting this one, sorry, let's have it 1 here, right? 1 1 2. Now selecting this element here, selecting this element here, this call will generate all the subsets which are having all the elements at index, starting with index 1, which is index 1, we have 1. So what I mean to say, the subsets generated here, subsets generated here will be a proper subset of this function called tree, right? So what we can do, we will not select this call, right? Because this function called tree will generate the duplicate subsets, right? If I can show you with some example, it would be much more clear. What I mean to say is, just a second, just a second. Right, now we are good. So let's say we are given this array. We have sorted the array, and the array is this 1 1 2. Okay, 0 1 2. These are indexes. Now we are at index 0, the data structure is empty. We will either select the element or we can reject the element. If we select the element, we will move to index 1 and element of 0 would be added to our data structure, correct? Again, we can either select or we can reject. Now if we select this element and 1, so we will go to second index and the data structure will be 1 comma 1. Again we can select 2, we would be at 3 and the data structure would be 1 1 and 2 2, right? If we reject this, if we reject this call, we will be at index 3 and the result would be 1 comma 1. Similarly, we are at first index. We are rejecting the first, so it would be 2 and 1, right? Again we can either select or we can reject, right? So it would be f3, and second is we are selecting, so 1 and 2, or it would be 3 and 1, right? These are the subsets generated by this left tree. Now if we will execute the right tree, we are not selecting, we would be at index 1 and our array list is empty. Again we can either select or we can reject. If we select one element at index 1, it would be added in our data structure, right? Now if we select or we reject, we would be at 3 and it would be 1 2. If we reject, so it would be 3, would be 1. If we reject this, so it would be 2 and empty. Now this will have, we can select or we can reject. So here we will get f of 3 and 2, and here f of 3 and empty. Right. Now if you see, here we are generating the subset 2 comma 1. Here we are generating this subset 2 comma 1 and 1. Right, so these subsets are also generated here, right, in this under this function called tree. Yep. So because the data of when we are selecting this, we are moved to 1. When we will go to we will select the data of 1, we will add 1 and we will remove 2. Right, so the element 0 element and 1 element is same, right? So this is 1. So this left tree will generate this left tree will generate the subsets which are proper subsets of this function called tree, right? Because the element are same, zeroth element and first elements are same, right? So if we are selecting first element, then the subset here are generated will be a proper subset of this whole left tree. So we have to ignore this, we have to skip this function call, right? Right, so how we will do this? We will simply say if the elements here are equal, then we can move to the next call, which is this one. Right, so simply if I show you by writing code, it will be much more clear. We are given, so we will have an array list of integer. We have an array list of array list of array list of integer, and say ans new array list. Now we will have another array list uh, of integer, in say data structure is equals to new array list, and can call the get uh, unique subset function, which will get an index, uh, nums, data structure and answer, right? So let's write this function static void int idx int nums. This is our data structure, and the last one is the answer. You can keep it here. Now what we will do, we will say if idx is equals to nums, idx is equals to nums dot length, then answer dot add new array list with the content of data structure, and we can return, or we can select. When we are selecting, we will add the current element into our data structure, nums of adx, and we will recurse to call this function for idx plus 1 nums yes and answer, right? With the left call there is no problem, but with the right call there is problem. So what we will do, we need to don't select call, we will remove the last added element. We have removed the lastly added element, and we will run a loop while idx is less than nums dot length minus 1, and here are nums of I is equal nums of I plus we can move the pointer to, this is not I, this is idx. We will say idx plus plus, and after that we can get a call for idx plus 1 nums ds and answer. See, so what we are doing here now, let me clear this. The issue is always with the right call when we are rejecting the element. After rejecting, we don't have to select the element which is already selected. Say here when we are selecting 0th element, so we are at first now, and 0th element 1 is added, right? So now this will generate all the subset which will have 1, which will include 1 in its element. Now if we are rejecting element 0, we are at first index and the subset is 0. Now if we will select this first element again, right, if we will select this first again, so what will happen, this the zeroth element 1 is same and the first element 1 is same, so all the this tree will generate all the subsets with zeroth element. Again, if we are at 1 first index, we are selecting this, so what uh, all the subset it will generate now would be a proper subset of this tree, right? So we need to skip that call. We need to skip that call. Once we have the left call, for the right call we have to check, right? If the element is same, then we have to uh, okay, the elements which generate here would be same. So uh, let's do a dry run one more time. We will get this better. One would be added. Again, we can select, again, we can reject. If we select, it would be 2 and first element would be added. If we reject, it would be 2 and 1 as it is, right? Again, we can select, again, we can reject. It would be 3 and 2, 1, 1. This will be our data structure. We reject, it would be 3 and 1, 1. Right here, if we select, if we reject, if we select, it would be 3 and 1, 2. If we reject, it would be 3 and 1. This call is ended. Now we will go with the right call, or where we are not selecting the first element, we are selecting, so it would be 1 and empty data structure. We can select it, we can reject it. If we select this, we will move to index 1 and 1 element would be added. If we reject this, we will be at 2 and it would be empty as it is. Again, we can select, we can reject. If we select, it would be 3 and it would be 1 and 2. We reject, it would be 3 and 1. Again, we can select or we can reject. If we select, it would be 2. If we reject, it would be empty, right? This is how it will go for this array. Now if you can see the subsets generated here, what all subsets it have generated to uh, this this call have generated duplicate subsets, which is 1, 2 and 1, right? This 2 and 1 is unique, but 1, 2 is already generated here and 1 is already generated here, right? So we need to skip this right call. We will check on this right call. We will skip this call. We will have this left call running and we can skip this call. Yep. So the code we have implemented almost. Just we need to transform the array. One more thing, we need to sort the 2D array as a whole. For sorting this 2D array, I will copy this function simply. I can copy this function and paste it here. Okay, sort 2D array, 2D list, sorry. So we can make a call to this with answer. Now it's sorted. Now we need to create an 2D array. So int res is equals to new int of it will have how many rows, a number of elements which are there in the sums dot length. Now we will run a loop for int I is equals to 0, I is less than, I is less than answer dot size. Hmm. Uh, we yeah, we have to transform this array into an 2D array, right?